We're going to talk about section 8.4, which is determinants. The determinant is a unique real number associated with a square matrix. Mathematicians often look for patterns in things in the real world, and when matrices are used for collecting data, they've been analyzed, and a while ago, mathematicians found this number, the determinant, that would help them discover other things about the data. So today we're going to just talk about how to find the determinant, and then in a couple of sections we're going to actually use it for solving systems of equations. So today, like I say, we're just going to talk about how to solve for the determinant and find what it is. Remember we call matrix by capital letters, so if we want the determinant of a matrix, matrix A, then we use these absolute value bars to show that that's what we're looking for, the determinant. Now, for a 2 by 2 matrix, and then notice we say it's always with a square matrix, it's got to be square. So for a 2 by 2 matrix, it's pretty easy. If we have this 2 by 2 matrix, and we want to find its determinant, then the way we write that is we say the absolute value bars over it, and we also, you can do that with the matrix itself, change the brackets to these bars like this. For a 2 by 2 though, it's really easy. Multiply the diagonals, So these diagonals minus these diagonals, and you end up with the determinant. So if we want the determinant of a matrix 2, 1, 0, 7, then we say 2 times 7 is 14, minus 1 times 0 is 0. So the determinant of this matrix is the number 14. Now, for the bigger matrices, it gets a little bit more complicated. We're going to work with 3 by 3s for our examples, but we'll look at some bigger ones in class as well. And there's two different methods that you can use for a 3 by 3. You can use diagonal products, so let's try that one first. And I'll show you what that means. And you can use these for a 3 by 3. So if we have a matrix and we want its determinant, and this is our sample matrix here, then if we want to use diagonal products, the first thing you do is rewrite the first two columns. So we'll rewrite those, and you just write them out next to it. First column, and then the second column. Then the next thing you do is you find the diagonal products. What does that mean? Well, basically you're multiplying everything on the diagonal. So what you do is you start here and we multiply down this way. We have 4 times negative 1 times 6, and that gives us negative 24. And then you multiply down this way. 8 times 5 times 7, and that gives us 280. And then go this way. Negative 3 times 3 times 0, that gives us 0. Then we're going to have to use the same colors again. Then we start at the bottom and we multiply up. So we have 7 times negative 1 times negative 3, and we get 21. And then we do this diagonal and we get 0. And then this diagonal, 6 times 3 times 8, and that gives us 144. So that's all our diagonal products. We just multiply down the diagonals. That's why we write these two columns here, so that we're getting all three in. Then you add the top together, and you add the bottom together. So we've got 21 plus 0 plus 144, which gives us 165. And then we have negative 24 plus 280 plus 0, which gives us 256. Then the last step is you take the bottom number minus the top number, and that gives you the determinant. So we have 256 minus 165, and that gives us 91, which is our determinant for this matrix. So rewrite the first two columns. You should put that in there, first two columns, and find the diagonal products. Multiply down the diagonal, and it really is best to write all this out. Draw your arrow, write the number. Draw your arrow, write the number. Then we say add all the top numbers together, add all the bottom numbers, and then bottom minus top, and that gives you your determinant. And that's using diagonal products. So let's try one more here. So here's another one we can try. Now I want you to pause the video and try this one on your own, and then we'll go over it. Now, first we rewrite the columns, the first two columns, and then we find our diagonal products. So we have 8 times 10 times negative 7 is negative 560. Negative 3 times negative 9 times negative 2 is negative 54. And 12 times 7 times 1 is 84. And then the top ones, negative 2 times 10 times 12 is negative 240. 1 times negative 9 times 8 is negative 72. Negative 7 times 7 times negative 3 is 147. So if we add those up, on the top we get negative 165, and on the bottom we get negative 530. So then we say bottom minus top. So that's adding, and we get negative 365. So check yours and make sure that you got that. So that's using the diagonal products. Now, there's another way that you can find the determinant with bigger matrices. We use something called expansion by minors. So we're going to have to define a few things before we get started on an example. So the first thing we need to do is, what's a minor? Well, a minor is the determinant of the smaller matrix that you get when you cross out the entries row and column. So if you have this matrix here, 3, 7, 1, 0, 5, negative 2, negative 1, 2, 4. If we want to find the minor of 2, that's this entry here. So what we do is we cross out the row and the column of that, and the minor of 2 is we take what's left. It's the determinant of this smaller matrix of what's left. So then we have negative 6 minus 0, which is negative 6. So the minor of 2 is negative 6. So that's the first thing we need, is the minor. Now the next thing we're going to need is the cofactor. The cofactor is negative 1 to the I plus j. Remember, I is the row number and j is the column number, times the minor for that entry. So for 2 above here, the cofactor for this is going to be -1. Well, this is in row 2, column 3, so to the 2 plus 3 power, times our minor, which is -6. Well, -1 to the 5th power, so any odd powers, it's going to be -1. So we have -1 times -6, which is 6. So this is the cofactor of 2. So what we need to remember is we've got to remember how to find the minor, and once we find the minor, then we can find the cofactor. Now, how do we use this to find determinants? Well, if we have, let's say we want to find the determinant of this matrix. Now, to find the determinant with expansion by minors, the first thing you do is you pick a row or column to go off of. Now, what do I mean by that? Well, what we're going to do is we're going to multiply each of the entries of that row or column by its cofactor. So what you want to do is you want to pick the easiest row or column to deal with. So if there's a lot of zeros in a row or column, then that's going to be the easiest one to deal with. Or like in this case here, this column here has 2 1s in it. It's very easy to multiply by 1. So the easiest row or column in this matrix to go off of is this one here, this 3rd column, because it's got these 1s in it, and those are easy to multiply by. Now once you've picked your row or column, then you multiply each entry by its cofactor. So what we're going to do is we're going to take this first entry here, -3. Now remember, its cofactor is -1 to the power, that's the row plus the column. So we've got row 1, column 3 power, and then times the determinant of what's left when you cross out the row and column. So we cross out this row and column, and we're left with this little matrix here, and we'll have to find the determinant of that. We're just going to write out all the pieces right now. Now we're going to end up adding all these, so I'm just going to write it in one line here. So then we take the next entry, 1, and then we have -1 to the, well, this is in row 2, column 3, and then we cross out the row and column for that and write down what's left, find the determinant of that. And then we take the last entry in that row we picked, and -1, well, this is in row 3, column 3, so we have 3 plus 3, and then find the determinant of what's left. Well, we cross out the row and column that it's in. Okay, so we've got our entries here times the cofactors for those entries. So now we just have to actually calculate what those things are. So we have -3 times, we have -1 to the 4th power, so it's even, so that means it's just times 1. And then this determinant here, remember with the 2 by 2, it's pretty simple. Multiply the diagonal, 6 minus, multiply the diagonal, so 6 minus 12, and that's going to give us -6 plus, and then we have the entry times, we've got -1 to the 5th power here, so it's an odd power, so it's going to still be negative. And then we take the determinant of this one, -18 minus -36, so that's 18. Let's see, put these in parentheses so it's easier to see. And then here we've got our entry times -1 to the 6th power, so it's an even power, so it's just 1. And then we've got 18 minus 18 is 0. So we have 0. So here we've got negative 18, or excuse me, negative times negative is positive, positive 18. And then plus negative 18 plus 0 equals 0. So the determinant of this matrix up here, this one, is 0. Could you have done it by diagonals? Of course you could have, but this is just a different method. And this is often more useful with the bigger matrices, bigger than 3 by 3. So I'm going to give you one here that I want you to try on your own using the expansion by minors. Okay, so pause the video and find this one using expansion by minors, and then we'll look at it. So we pick a row and or a column to go off of. I'm going to choose this one here because it has a 0 in it and it's got smaller numbers. You could use this column if you wanted, but then you've got this negative 7, it's a little bigger. In the end, you should end up with the same number no matter what row or column you picked. So we've got 1 times negative 1 to the, this is row 2, column 1. So 2 plus 1 power times, we cross that out, we have 2, 5, negative 7, 6, plus, and then this one we've got 0 times negative 1 to the, we're in row 2 and column 2, negative 3, 5, 4, and 6, because we cross out the row and column that's in. Now, did I have to write all this out? Not really, because I knew it was going to multiply to be 0. So we're just writing it out for illustrative purposes right now. 2 times negative 1 to the, this is row 2, column 3, power. So we cross out what we've got, and we end up with negative 3, 2, 4, negative 7. So now we just calculate this. Well, 1 times negative 1 to the third is negative 1. So that's going to be negative 1. We've got 12 minus negative 35. So that gives us 47 times the negative 1 is negative 47. We know that one's 0. We don't have to calculate any of that stuff out. And then here we've got 2 times negative 1 to the fifth. So that's negative 1. So that's negative 2. And then 21 minus 8. 21 minus 8, right, 13 times negative 2 gives us our negative 26, and we end up with negative 73. And you should have gotten that no matter what row or column that you used. This works for bigger square matrices as well. Now, that's how you find a determinant. There is one thing that you need to know about these. You need to know what the transpose is. That just switches the rows and columns. And the way you would write that is like if you had a matrix A and it was this one here, then its transpose is written with a little T at the top, and it switches, so row 1 becomes column 1 and row 2 becomes column 2. Now, how is that relevant to this lesson? Well, when you have a determinant, the determinant of a matrix is equal to the determinant of its transpose. So you'll need to know that. Like I say, for this lesson, the biggest thing is knowing how to find determinants, because we're going to use it and apply them in later lessons. So make sure that you understand how to find a determinant. The 2 by 2s should be no big deal, but the 3 by 3s and bigger, you need to know how to use the diagonals and especially the expansion by minors. So read the section, and we'll talk about this some more in class and do some bigger matrices.